can you solve this algebra challenge? Here's the question. If 3a plus 2 over square root of a equals 1, then what is the numerical value of a minus square root of a? Now you can pause this video if you want to give this problem a try. Now suppose you pause this video. Now let's see if you got the correct answer. Alright, so given this equation, 3a plus 2 over square root of a equals 1, then our goal is to find the numerical value of this expression a minus square root of a. Now, one observation right over here is this square root of a on the denominator. Since square root of a is in the denominator, it follows that square root of a cannot be equal to 0. Alright, so let's have this condition that square root of a is not equal to 0. This is very important because what we're going to do is to multiply the whole equation by square root of a. Since we know square root of a is not equal to 0, we can definitely multiply both sides by square root of a. Therefore, we have 3a multiplied by square root of a plus 2 equals square root of a. Now, equate this to 0. And we have an equation 3a times square root of a minus square root of a plus 2 equals 0. And our goal is to find this expression. Now, here's the trick. I will tell you that this expression on the left-hand side is definitely factorable. This is not obvious, but this expression is factorable. Now, I will show you. So, let's focus on this expression, negative square root of a. So, we can rewrite this as 2 times square root of a minus 3 times square root of a. Now, the question is why we choose 2 squared times square root of a and 3 times square root of a. Here's the reason. Because we have 2 here and we have 3 right over here. So, maybe those expressions are the key to factor the left-hand side of our equation. So, let's replace negative square root of a by 2 times square root of a minus 3 times square root of a, like this. Alright, now, let's focus on these two terms, 2 times square root of a plus 2. So, take note, we can factor out a common factor of 2. So, 2 times square root of a plus 1. So, we can replace this by its factored form. And now, on these two terms, take note that we have also a common factor of 3 and square root of a. So, 3 times square root of a. So, if we factor out this common factor, we have 3 times square root of a multiplied by a minus 1. So, let's replace this by its factored form. And one thing to notice here is we have different factors, a minus 1 and square root of a plus 1. But, take note, this a, we can rewrite this as square root of a raised to the power of 2. Now, we have a square number minus another square number. So, we can factor this using difference of 2 squares. And if we factor this out, we get square root of a minus 1 multiplied by square root of a plus 1. Now, you can see now a common factor, square root of a plus 1. And if we factor this out, we can multiply this by this factor 3a times square root of a minus 1 plus 2. Now, we can simplify this. We can multiply 3 times square root of a by square root of a and by negative 1. So, this will give us 3a minus 3 times square root of a. And now, since it is equal to 0, applying the 0 property, so we can say that all of these factors must be equal to 0. And now, here's the thing. We want the value of this expression, so we don't care to the value of a. So we don't want this first factor. In this factor, we get the value of a, but we don't care the value of a. Our goal is to find the value of this expression. So, let's have the second equation that says that 3a minus 3 times square root of a plus 2 equals 0, because if we factor out 3 in this expression, we get 3 times a minus square root of a, and this is the expression that we want to evaluate. And to find the value of this, let's subtract 2 on both sides, and divide both sides by 3. And we get that a minus square root of a is definitely equal to negative 2 over 3. And that is the answer to this question. Therefore, if 3a plus 2 over square root of a equals 1, then the numerical value of a minus square root of a equals negative 2 over 3. And as always, we are done.